From the food we eat to the air we breathe, we are all part of the carbon cycle. Yet, through our dependency on fossil fuels, our daily lives often have a negative impact on the climate.
Currently, the food and beverage industry is a major contributor to the greenhouse effect, responsible for over 1/3 of global emissions. These industries rely on energy-intensive processes such as heating, cooling, and refrigeration. And when powered with fossil fuels, these processes are the primary cause of food and beverage emissions and negative climate impact.
Energy prices fluctuate due to political dynamics, supply disruptions, seasonal variations, etc., and a significant portion of a food and beverage company's expenses are often allocated to energy costs. During the global energy crisis, the price of gas alone rose dramatically, ranging from €30 per megawatt hour to €350 per megawatt hour. Many companies in the food and beverage sector are heavily dependent on fossil fuels. This reliance can expose them to unpredictable price fluctuation, making it challenging to control energy costs and sustain their profitability. In addition, growing consumer and financial concerns about climate change are putting pressure on these companies to reduce their emissions and adopt to cleaner energy sources to decarbonize their industry. Also, upcoming regulations, such as the European Parliament's Fit for 55 energy efficiency target, compel companies to embark on the journey towards sustainable energy transitions. This transition is not just an obligation, but an opportunity to build resilience against energy price volatility and reduce fossil fuel dependence. The food, beer, and beverage industries can adopt various sustainable practices to reduce their environmental impact. This includes sustainable agriculture practices, renewable electricity, waste recovery, and eco-friendly packaging. When analyzing the energy consumption of these industries, a prominent fact emerges. Heat constitutes more than 70% of their total energy consumption and is a primary contributor to the industry's carbon footprint. This heavy reliance on heat presents challenges, but also opportunities to decarbonize and dramatically reduce CO2 emissions, optimize the energy use, and minimize costs.
Nevertheless, there is no silver bullet for renewable heat and decarbonization. An in-depth approach is necessary to reduce dependence on fossil fuels and improve energy efficiency. What proves crucial is the implementation of a comprehensive strategy that tailors technologies to meet the unique requirements of each facility.
Knowing which technology to combine requires a broad understanding of the different renewable energy sources available. With the widespread electrification of society, demand for electricity is increasing worldwide, requiring significant investments in the power grid. Based on current estimates, these investments will need to increase from $300 billion to $700 billion annually by 2030. This calls for policymakers to encourage grid upgrades, though this vast effort may slow the transition to greener energy through electrification. When it comes to heat supply, electrification frequently implies the use of heat pumps. Heat pumps can be up to 3 times more efficient than electric heating, providing 3 units of heat for each unit consumed. Nevertheless, price of heat and the environmental footprint of heat pumps isn't consistent and largely depends on the type of electricity used. For instance, in areas where the electricity grid is primarily fueled by fossil fuels, heat pumps can indirectly contribute to CO2 emissions. Therefore, the integration of renewable heat solutions should go hand in hand with concerted efforts to secure a power supply that originates predominantly from renewable energy sources. Another available renewable heat source is biomass. Biomass generate heat by burning organic materials like wood chips, sawdust, and agricultural waste. However, its use has certain drawbacks, such as competing for land with food production and emitting carbon dioxide and other air pollutants. Biomass is expensive to generate and is limited by geography and weather patterns. The burning of green sources also runs the risk of becoming illegal or incentivized out of existence. Hydrogen, as a renewable heat source, has the potential to address global energy and climate change challenges. While still in the research stage, significant advancements are being made to produce hydrogen through electrolysis using renewable energy sources. Hydrogen offers several advantages, including zero emissions at the point of use, high energy density, versatility, and integration with renewable energy. However, challenges remain, such as high production costs, infrastructure investments, and public acceptance and safety concerns. One effective approach to reducing reliance on fossil fuels, cutting production costs, and mitigating climate change impacts is the application of solar thermal. Solar thermal provides a solution to the industry's high heat demand, as the sun serves as an unlimited source of clean, reliable, and easily accessible heat that can be harnessed endlessly. In addition to being cost-effective, solar thermal energy is also price predictable, preventing the risks associated with price volatility. The technology is readily deployable and is not constrained by factors such as availability, electricity prices, and grid limitations. According to the International Energy Agency's Net Zero by 2050 report, solar heat is projected to meet 11% of the industry's heat needs by 2050, particularly at temperatures up to 200 degrees Celsius. This accounts for a quarter of all heat requirements, which requires the use of solar collectors covering over 1.3 billion square meters. In 2022, industrial solar heat installations increased by 50%. And food and beverage industry is the dominant sector in solar thermal installations. When considering solar heat technologies, it is essential to choose the right type of solar collectors. There are various options available, each with its unique features and benefits, and steam and hot water ranges. Absolicon T160 is a small parabolic trough collector that provides steam up to 160 degrees Celsius and pressure up to 8 bar. It features a built-in tracking system that follows the sun throughout the day, along with a glass cover that is self-cleaning for low maintenance and enhances the collector's lifetime. The collector's lightweight design also makes it ideal for elevated structures and rooftop installations, offering versatile and space-efficient solar thermal solutions. At Absolicon, our team of renewable heat experts is dedicated to helping industries decarbonize. With over 20 years of experience and more than 11 years of operational installations, our focus has been on crafting top-tier solar thermal solutions. With the highest optical efficiency ever measured for a concentrating solar collector, the Absolicon T160 has its performance certified in both Europe and North America. Our systems are designed with sustainability in mind, minimizing reliance on rare or polluting materials and ensuring recyclability at the end of their lifespan. We offer versatile heat and storage solutions adaptable to any location. Whether you prefer to own and maintain your system or opt for heat as a service, Absolicon provides flexible options tailored to meet your specific requirements.
We believe in local production of our solar collectors, which not only reduces their costs, but also minimizes environmental impact through reduced transportation and adaptation to local conditions, contributing to the low LCA index of the collectors. Your journey to net zero starts with informed decisions and trust solutions provider with the expertise to guide you forward.